A couple of months ago, my programming student programmed this game that you see here. He coded it using HTML, CSS, and JavaScript. You play as this rocket ship aided by 4 different cannon turrets, and your goal is to survive as many waves as you can of these asteroids. Now, this example doesn't fully represent his game because, as you can see, there are some bugs here, but this wasn't his final product. Now, that aside, I thought it would be cool if I replicated his project and showed you guys how you can make your own asteroid ship dodging game here. So what I've done is I've created a folder, which I'm going to put in the description. Go ahead and download this folder. This will contain a blank JavaScript file, a blank HTML file, a blank CSS file, and all the textures and sound effects that you'll need to follow along and create this game. Now, there's going to be 2 parts to this video. I'm going to try to make the second one tomorrow, and I am going to move pretty quickly. This will require prior programming experience, but you can check out my making browser games tutorial list in case you need to get caught up on that. So with that, let's go ahead and start. I'm going to open up my editor, which is going to be Notepad++, and you can see here I have all 3 files and my blank HTML file here. So let's start with the HTML. We're just going to fill in the basics. So create the doc type HTML, and then I'm going to create the HTML element. Now I'm going to create the head element and link this HTML file to our CSS. Well, first I'll give a title. So create a title element, game replica / title. And now we'll link this HTML to the CSS. Link href equals style.css. If you do rename the CSS file, you will have to change this name. Rel equals style sheet. Like that. So now this HTML is linked to the CSS. Let's go ahead and link the JavaScript as well. So I'm going to create the body element. And I'm going to add the JavaScript at the end. Script source equals code.js / script. And now let's create the canvas, which is what we're going to be using to render the graphics. We're going to be using HTML canvas to render all this here. So I'm going to create the canvas tag. Canvas. I'm going to set the width to be 1,200 pixels. I found that to be good. And the height will be 500 pixels. And I'm going to close that with the closing canvas tag. I will need to give the canvas an ID. ID equals canvas. And now we're ready to start coding this game. So in the code in the JavaScript file, we're going to grab the canvas, var canvas equals document.get element by ID canvas, like that. And then we're going to grab the context, which is the rendering tool from the canvas. So var context equals canvas.get context to D. And actually make sure that D is lowercase. That will cause some problems. So we have the canvas, we have the context. Let's go ahead and set up the primary game loop. So a game loop is just the series of functions that repeats in a game. This game here is really just 2 functions repeating over and over. Drawing, which is where the screen is refreshing and you see the asteroids moving, and updating. That's where the positions of the asteroids move, the star positions move, the bullets move. Anything that has to do with a change of data in our game is an update. So we're going to set up that loop. We're going to repeatedly have an update function and a render function. So I'm going to create the update function. And I'm going to create the render function. And for now, they are going to be blank. Finally, I'm going to create a play button, or play function, that will run both of these 2 functions. Function play, and all this function will do is run update, and then run the render function. This is a primary update function for a game, primary render. Now, nothing will happen. We need to make the play function run at 60 frames per second. So I'm going to type set interval play is the function we're going to use, and you're going to type here 1000 divided by 60, and that just means 60 frames per second. So this play function will be running at 60 frames per second. Let's prove that. I'm going to add console.log update just so we can see visually that the update is happening, and console.log render. Now go ahead and open up your index.html file and refresh, and let's open up the console. And we see update and render running repeatedly, so that's good. That means everything is working so far. I don't see the canvas on my screen, so let's go ahead and in our CSS, let's put a border line around that canvas. So I'm going to create a CSS rule, canvas, border, colon. It will be a 1 pixel, 3 pixel, solid black line. So save that file, and now I can actually see the canvas, which is right here. Now, I want it to be centered. I believe my student centered it here, so I'm going to center it as well. To center it, I'm just going to add this code. I'm going to add margin auto and display block. Refresh, and now our console is centered. And we'll worry about lowering a bit so that we can have the wave count here later, probably in part 2 of the video. Okay, so now that's set up. Let's go ahead and get that black background. So in the render function, instead of just console logging, yeah, that's what it's called, console logging. Instead of logging messages, we're going to render a black background. So context.fill style, we need to set the default color for the drawing tool to use. That would be black. And now that the context is drawing color has been set, we can type context.fill rect. This means fill a rectangle, and the rectangle that we're going to draw on the screen is going to be the exact size of the entire canvas. So we're going to fill this whole thing with a background color. So we're going to start the X position at 0, the Y position at 0, the width will be canvas.width, and the height will be canvas.height. Save your file, refresh, and now the background is black. And in fact, these are two pretty important numbers, the width and height of the canvas. So let's go ahead and create some variables for that. Const screen width is going to be canvas.width, const screen height. In fact, I like H for short, and we're going to use W for short. Screen height equals canvas.height. And I'm going to replace those values with these constants here, just because I foresee us having to use these over and over again. So it's better to just type screen W than canvas.width. Refresh to make sure nothing went wrong, and nothing did. Alright, so now let's go ahead and draw the player onto the screen. This is probably going to be one of the more complicated parts of the video, but just follow along, pause as needed, you'll be fine. I'm going to create a sprite class. This is going to be anything on the screen that we need to draw. So I'm going to type class sprite, and I do have a video explaining how classes work if you need to watch that. I'm going to give the constructor for the sprite, and the constructor will require 5 parameters, an X, Y, width, and height to start with, as well as a texture to use. The sprite isn't going to decide any of these for itself. These will come from the parameters. So let's go ahead and create some private variables for those parameters. This.x equals x, this.y equals y, this.w for width equals w, this.height equals height, and this.texture equals texture. And we're going to worry about how to actually load textures later on. That'll be pretty easy to do. Now the sprite is just this box given a texture, and it's going to use this render function. We're going to give the sprite a render function, and in this render function, it's going to render the image there. So context dot draw image. This is a function, and it takes these arguments. The first argument is the texture, so we're going to use the sprite's texture variable, and then just the dimensions, or the destination rectangle, as some people call it. So this dot x, this dot y, this dot w, this dot h, and then end that with a semicolon, of course. So now the sprite class is set up. Now we could use the sprite class and start drawing the player, but I actually want to I want to create a separate class for the player itself. The player is going to inherit from the sprite. It's going to borrow all these default variables and this render function. So I'm going to create the player class. Class player extends sprite. And this is so that basically every object in our game is going to have to reuse the same code. So this makes it to where I don't have to type the same code over and over again. So I'm going to create the player's constructor. And the player's constructor will only have an x and a y as the parameters. And I'm going to, from the player's constructor, call the sprite's constructor using the super function here. So super is really just calling the constructor of the superior class, which is sprite, so that's this constructor here. But before we do that, we need to actually load the player's texture. So let texture be new image. That's how you load a text or create an image object. And now we have to set the source for this texture, or what it actually is. Texture.src source is equal to, and now this is where we're going to hop over to your file here. I called the file for the player player.png. So we're going to go ahead and use that, player.png. So as a string, player.png will be our source. And now let's go ahead and create some constants as well for the player width and height, since those are not going to be changing. X and Y will, but width and height will not. So const player width will be, let's just say 50 for now. Const player height will be 30. And in fact, let's make that 60-30. I actually don't know for sure what that's going to look like, but we can easily change it later. So now that we have an X and a Y, which we'll decide later, a width and a height and a texture, we can call the sprite's constructor. X, Y, player width, player height, and texture. Like that. Now the player is also going to need a speed variable. This dot speed, and I'm going to set that to 4, even though we're not going to use that for a bit. And the player is also going to need an update function, but for now we're going to skip that as well. So all we're going to do is draw the player. So now that we have the player and sprite classes set up, let's go ahead and create our player object. Var player equals new player. For his X and Y, I'll put his X position to be maybe 300, his Y as, let's see, what was the height? I set the height to be 500, so I'm going to put maybe 240, which will be roughly the middle in the Y axis. So there's our player. Now, the player will have an update function later, but we don't need that now. Let's call the player's render function from our primary render function here. Player.render. Like that. And now I'm going to refresh. And look at that, first try, the player rocket is now on the screen. Alright, so now let's continue with the player's movement. For the movement, remember I said update is basically any change of data in your game. So if the player is going to move, that's definitely a change in data. So we're going to need an update function for the player. Update, like that. And the player's update function, essentially what's going to happen is if the W key is pressed, he'll move up. And if the S key is pressed, he will move down. And we're actually going to move on from this because we need the event listeners first. Event listeners are how our window is going to keep track of when the user presses a key. So I'm going to add an event listener at the bottom. Window.add event listener. The event that we are listening for is key down. And the event function handler will be function with a parameter called E. That just stands for event. And I'm going to end that with a semicolon. I'm not talking about syntax a whole lot because I'm assuming you already have programming experience, but be careful about this part. It's an opening parenthesis here, function. Function has its own two parentheses here, a curly bracket, another curly bracket, and then this parenthesis here actually is the closing parenthesis for this one here. And then you have to end the line with a semicolon. So just pause and make sure you got that right. So this is the event handler for when the user presses a key. We need to figure out what that key is. So I'm going to create a variable. Let the key be the e.key, so whatever the event's key was. And now we can do some logic on this. If the key that was pressed is equal to w, then player.y minus equals player.speed. Like that. And don't let the minus confuse you. In Canvas graphics, when you go up, the y gets smaller. It's flipped. Now, if the key is s instead, then player.y, we will add the player speed to that. And now we've used our event listener here. We can go ahead and refresh, and the rocket is responding to key input. Now you'll notice that it moves pretty slowly. Let's see what the original was like. Oh, it's going crazy here. So the original has smooth movement like this, and it moves a bit faster. So I'm going to show you guys how you can make the movement a little bit smoother like this. So the way we smooth things out is we need to actually create a keyboard dictionary. It's just a JavaScript dictionary that's going to store the key states of W and S. A key state is false if it's not pressed and true if it is. And we'll see why this will help us in a second. So right above the player, I'm going to create that dictionary. Var keys is equal to. And again, if you're not familiar with a dictionary, it's like a list, except it's a little bit more complex. It's like a list of different variables which can have changing values. So I'm going to add W as our first key value pair, and then I'm going to add S as well. So W is the key. False is the key state. S is another key. False is the key state. We'll actually need one for space later on when we start shooting, so let's just add that. Space, false. So now what we're going to do is in the event listener, instead of directly modifying the player's position here, what we're going to do instead is if the key W is pressed, we're going to update the key dictionary here, and we're going to change the key state to true. So I'm going to add keys W equals true. Same with S. In fact, I'm going to copy since I'm a little lazy. Keys S equals true. And let's go ahead and add one more for the space key. If key equals, and I actually don't remember if this is the word space or just the blank space. We'll see that later once we start doing the shooting. Keys space equals true. All right, and that's great and all, but as soon as the problem with this is we are only detecting when a key is down. We should turn the key state back to false once the key is lifted. So in fact, we're going to create another event listener. Window.add event listener. This time the event is key up, and we're going to create our handling function like normal. Let's grab whatever key was pressed. Let the key be the event.key. And I'm actually going to copy all this stuff here. If the key W is pressed, but from the if the W was the event, but we're from the key up event listener, we got to change the key state to false. And I'm just going to change all of these to false. So now what we're doing is we're saving the key state of each individual key inside of this keys dictionary. And with that, we're going to process this in the player's update function. So in the player's update function, I'm going to add if keys W equals true, or I can just do if keys W for short. So if the W key is currently on, then I'm going to write this dot y minus equals this dot speed. And then if keys S is true, then this dot y plus equals this dot speed. And I'm going to save that. Now, nothing takes place until we actually repeatedly call the player's update function. So from our main game function, we're going to call that player.update so that we can actually use the keys. So save your file, refresh, and now the player is moving much like the original did. And it says I win, but that's because I wasn't even taking any hits. That's something, again, that's not something my student did. I grabbed an old copy of his game that wasn't working. I don't know why I talked about that. Oh yeah, I wanted to show you the ship right here, moving nicely. We got it just like the original one. So now what we're going to do is go ahead and add the asteroids. And in fact, that's the last part of this video. We're going to add the asteroids and give them the ability to randomly spawn and move from the right of the screen to the left. We're not going to worry about the bullets. We're not going to worry about the collision detections. But we'll add the asteroids. So the first thing I'm going to do is I'm going to create an asteroid spawner or an asteroid manager. It's basically going to spawn the asteroids and handle when they should be deleted. And in fact, I'm going to do this right above the player here. So I'm going to create that class asteroid manager, and I'm going to create a constructor for this class, constructor, and it won't need any parameters. Alright, the asteroid manager will contain a list of all the asteroids in the game. So this .asteroids equals just an empty list for now. And we'll create the asteroid class in just a second. Now the asteroid manager is going to need two more variables. A timer, so this .timer equals 0. And it's going to need a delay time. This .delay equals, and I'm going to set the delay to be maybe 100 frames. So the way the asteroid manager will work is it's going to set the timer to be delay. Then the timer is going to count down, and once it hits 0 again, then we spawn an asteroid, and then we set the timer to delay again. So it's this constant loop of counting from 100 down to 0, and then spawning an asteroid. So we're going to need to do that in the update function. So let's have it to where the timer, in fact, the timer needs to start as the delay. So this .delay, the timer will start at 100. So from the update, we're going to decrease the timer, this .timer minus. And then we're going to check if this .timer is equal to 0. Then what we need to do is reset the timer back to delay. This .timer equals this delay, and here's where we would add the creation of an asteroid, but we needed an asteroid class for that first. So let's create that class. And this class is also going to inherit from sprite because the asteroid is a sprite. It has all the same data. So right below, I'm going to create the asteroid class. Class asteroid. Add the constructor. The asteroid will, just like the player, it's going to take X and Y as parameters because those will be decided by the asteroid manager, but the size is going to be consistent. So let's create some constants. Const asteroid width will be, and let's just make it 100 by 100. So const asteroid height equals 100. I could just reuse this constant here, but I also want to make sure that if I later want to change it to where these are not squares, I want to have this one ready. All right, now, just like what we did for the player, let's go ahead and generate the asteroid texture. So let the texture be new image, and then texture.source equals asteroid.png. I'm going to double check real quick, make sure that's what I called it. Yes, that is what I called it. Now that we have the texture loaded, we can call the sprites constructor and finish setting up the asteroid. So we're going to use X, Y. I'm going to copy these. Asteroid width, asteroid height, and texture. Now the asteroid update function we can actually start right away. The update, all that will happen is the asteroid's going to move to the left. So what we're going to do, and we're going to need a speed of the asteroid as well. We'll set it to the same as the player. This .speed equals 4. And now for the update function, all we're going to do is make it move to the left. This .x minus equals this .speed. So now we're good with the asteroid. We can start creating some asteroids. So let's hop back to the asteroid manager. here's the timer. The timer starts at 100. We minus it every frame. Once it hits 0, we're going to reset it to 100, and then we're going to create an asteroid. So I'm just going to call it A, B, new asteroid. Oh, and we actually need an X and a Y. So we know the X, the asteroid, needs to be all the way over to the right. So that's just going to be the screen width for the X. But the Y needs to be a random number, just a random height from here to here. So let's create that random height. Let rand y be, and if you're unfamiliar with how to do random numbers in JavaScript, I have a video for that too. Just check that out. But here's all the code. Math.floor, math.random times, and I'm not going to worry about the actual size of the asteroid. I'm just going to write times screen height, and that with a semicolon. All right, so we have a randomly generated y position. So let's add that, rand y. And now the new asteroid has been created, but it's not official until it's added to the list. And by the way, in order to add it to the list, we will need an asteroid count. So this dot num asteroids, and we're going to set that to 0. You don't need this variable, but it will be pretty useful. So now I'm going to write this dot asteroids, and in the brackets, I'm going to write this dot num asteroids equals A. So now this line of code officially adds that new generated asteroid from this line into our list here. So this will handle the creation of new asteroids, but the asteroids don't actually update and they're not rendering right now. So in fact, after we do all this logic, let's use a for loop and update all the asteroids that we have. For let I be 0, I will be less than this dot num asteroids, I plus plus. Oh, and by the way, very important, I forgot. Now that we've created a new asteroid, we need to add one to our count. So this dot num asteroids plus plus. All right, so now let's finish our for loop, which will run the update for each individual asteroid. We're going to type this dot asteroids I dot update. And now we're actually going to create a render function for the asteroid manager as well. And this is going to do the same thing. It's just going to call the render function of each asteroid that we individually have in our list so that we see them in the game. So I'm going to copy the for loop, and the only thing I'm going to change is the function call right there. And by the way, you might be thinking the asteroid manager isn't itself actually drawing, but I am using this function as a convenient way of drawing all the other individual asteroids itself. So now our asteroid manager is set up, our asteroid class is set up. Let's go ahead and at the bottom create the manager. Var, I'm just going to call it manager since I don't think we'll have any others, equals new asteroid manager. And now we're going to need to update the manager. Manager.update. And we're going to call the manager render function. Manager.render. And now I'm going to save. It's very likely I made a mistake, and I did. What I'm going to do is pretend I totally didn't pause the video just to find what the error was. So when we created the asteroid is calling the constructor of a superior class, but I forgot to make it inherit from the sprite. So we need to add extends sprite, and that's it. So go ahead and refresh your page, and now you have your moving rocket, and asteroids begin to spawn, and you can dodge them even though nothing happens once you do hit them. So now we're almost at the end of this video, but I do want to add something right now. The asteroids are spawning infinitely, and they're moving just further and further and further to the left, and what they should do is they should delete once they reach all the way to the left side of the screen, just so that we don't create thousands of objects and our game starts lagging the longer we play. Let's add that. So we're going to modify the asteroid update function. What it will do, this update function is actually going to return true if the asteroid needs to be destroyed, and it will return false if it doesn't. So after we update the position, we're going to check. If this.x is equal to 0 if we're all the way to the left side of the screen, then let's return true so that we can signal to the asteroid manager that we need to be deleted, and then we'll return false otherwise. So now let's manage that from the asteroid manager. Over here, when we're calling the update functions, we need to actually find out what that return value is. So let destroy be the update result, and then if destroy, then we need to destroy that asteroid, obviously. So to destroy the asteroid and remove it from the list, we'll type this dot asteroids, actually dot splice. So this is the function that will remove an item from a list. We're going to remove the item at index I, and we're only going to remove one item. That will destroy the asteroid. Now to keep from any bugs happening, we're going to also update the count. And in fact, I don't like this variable name here, so I'm going to go ahead and rename it to count. So count, 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 and count, but you can name your variables whatever you'd like. So now this dot count minus minus. So now what should happen is the asteroids should delete the moment they reach the far left side of the screen. And actually, it looks like they're all deleting. Let's see what happened here. I made a pretty simple mistake in being OCD and renaming my variable. I forgot to rename the variable from the render function. So if you chose to rename yours, I'm going to do that here. So change num asteroids to count. Then refresh. And now what we have is the asteroids will fly all the way to the left. And as soon as they touch the left side of the screen, they delete, which actually kind of looks bad. I'd rather they delete once they're fully off the screen. And here's why. When it comes to rendering in Canvas, the actual X position of a sprite is the corner of the sprite, not the middle, the corner. So this is the X position, and this will reach the left side of the screen faster than all the rest of it. So that's why it's deleting early. So now let's go ahead and change some of our code just a little bit to account for that. Instead of deleting as soon as x is 0, let's actually delete once x is equal to the negative width of the asteroid. So asteroid width. And now that will force the asteroid to go all the way through, and the moment it's off the screen fully, then it will delete. So now let's refresh that. And let's test it out with this. And now it is in fact deleting. And if you wanted to make sure it was deleting, you could add a console.log statement here. Thank you very much for watching. This will be the conclusion for part 1 of this video. I plan on doing part 2 very soon so that you can be building your own cool asteroid dodging game.